In 1900, Greek sponge divers pulled something impossible from the Mediterranean seafloor. The Antikythera mechanism, a 2,000-year-old bronze computer that tracked planetary movements with precision we didn't achieve again until the 20th century, shattered everything archaeologists thought they knew about ancient capabilities. But here's what they discovered next, and why it terrified them. The device wasn't alone. Locked away in museum storage rooms and classified archaeological reports lies evidence of an ancient arms race that officially never happened. Self-firing crossbows from China that reload automatically. Heat ray weapons that incinerated Roman fleets. Damascus steel embedded with nanotechnology. Mayan obsidian blades are sharper than modern surgical instruments. Roman concrete that repairs itself after 2,000 years. Each discovery was quietly catalogued, studied, then buried in academic papers no one reads. Because if ancient humans could create technologies we're only now rediscovering, what else have we lost? And more importantly, who decided we weren't ready to remember? The basement of the National Archaeological Museum in Athens stretches deeper than most visitors realize. Beyond the marble statues and painted pottery displayed upstairs, past the climate-controlled chambers where conservation work never sleeps, lies a section that doesn't appear on any public map. Here, in rooms accessible only to researchers with the highest clearance levels, sits the collection that challenges everything we think we know about human technological development. Dr. Elena Marchetti learned this the hard way. When she first requested access to study the Antikythera mechanism's companion pieces in 2015, the curator's expression shifted from polite interest to something approaching alarm. "What companion pieces?" he asked, though internal emails later revealed he knew exactly what she meant. 3 months of bureaucratic delays followed. When approval finally came, it arrived with restrictions so specific they seemed designed to prevent meaningful research. 2 hours maximum, no photography, no detailed notes, and a chaperone who insisted on standing close enough to read over her shoulder. What awaited her in that underground chamber defied rational explanation. Arrayed across custom-built storage systems were dozens of artifacts that shouldn't exist according to conventional archaeological timelines. Bronze gears with tolerances requiring machine tool precision. Optical devices carved from single crystals with no tool marks visible under magnification. Metallic alloys that analysis suggested contained elements that shouldn't have been available to ancient civilizations. Each piece carried the same classification. Anomalous dating. Further research required. The official term for these objects is OOPArts, out-of-place artifacts. But that clinical designation masks the profound discomfort these discoveries create within academic circles. When carbon dating and archaeological context suggest an artifact is 3,000 years old, but its technological sophistication demands manufacturing capabilities from the 19th century or later, the cognitive dissonance becomes almost unbearable. Rather than challenge fundamental assumptions about human technological progression, institutions have chosen a different path. Quarantine the problem. This pattern repeats across major museums worldwide. The British Museum maintains a special reserve collection, accessible only to senior researchers with Ministry of Education approval. The Smithsonian's off-site storage facilities house hundreds of artifacts that never see public display, their existence known only to a small circle of specialists who speak in careful euphemisms about contextual anomalies and dating inconsistencies. Even private collectors who stumble upon such objects often find themselves approached by mysterious buyers offering prices too generous to refuse, after which the artifacts vanish into private collections or disappear entirely. The storage protocols themselves reveal the depth of institutional anxiety surrounding these discoveries. Standard archaeological artifacts are catalogued with detailed provenance, photographed extensively, and made available for academic study. The anomalous pieces follow different rules. Their documentation often consists of handwritten notes stored separately from digital databases. Photography, when permitted at all, captures only partial views or specific details rather than complete objects. Most telling of all, researchers studying these artifacts must sign agreements that go far beyond typical academic confidentiality clauses, including provisions that could end careers for unauthorized disclosure. Dr. Marchetti's experience represents just one thread in a much larger tapestry of suppression. According to leaked correspondence between major institutions, an informal network has existed for decades to identify and isolate artifacts that threaten established historical narratives. The process begins when an object demonstrates technological sophistication inconsistent with its archaeological context. Rather than publish findings that might generate uncomfortable questions, researchers are encouraged to conduct additional analysis, a process that can stretch for years while the object remains safely out of public view. The justifications for this approach vary depending on the audience. To fellow academics, the explanation centers on protecting institutional credibility. Extraordinary claims require extraordinary evidence, goes the standard response, and we must be absolutely certain before challenging established chronologies. To government officials who occasionally inquire about specific discoveries, the concern shifts toward preventing public misunderstanding of complex archaeological issues. To the rare outsider who learns about these collections, the final line of defense invokes national security. Some knowledge, they suggest, might be too destabilizing for public consumption. But what exactly makes these artifacts so threatening? The answer becomes clear when examining them not as isolated curiosities, but as components of a larger pattern. Each impossible object suggests technological capabilities that officially didn't exist for centuries after their creation. Taken together, they paint a picture of ancient civilizations that possess knowledge and manufacturing abilities that surpass our modern understanding of technological development. This possibility raises questions that extend far beyond archaeology into the very foundations of how we understand human progress. Consider the implications if these objects are authentic examples of their alleged age. The bronze computers would suggest mathematical and astronomical knowledge that surpassed anything achieved in the ancient world according to conventional timelines. The precision metalwork would require manufacturing techniques that weren't developed until the Industrial Revolution. The advanced optics would demand understanding of physics and chemistry that allegedly didn't emerge until the scientific revolution. If even a fraction of these artifacts represent genuine, ancient technology, then our entire model of human technological development becomes suspect. This possibility creates a cascading series of uncomfortable questions. If ancient civilizations possessed such advanced capabilities, why did this knowledge disappear? Were there deliberate efforts to suppress technological advancement? Did catastrophic events repeatedly destroy accumulated knowledge? Or perhaps most unsettling of all, has there been a continuous pattern throughout history of suppressing technologies that might threaten existing power structures? The pattern of institutional secrecy surrounding these discoveries mirrors historical precedents that give credence to such concerns. Throughout recorded history, technological knowledge has been treated as a form of power, closely guarded by those who understand its strategic value. From the Egyptian priesthood's monopoly on certain mathematical principles to the medieval guild's protection of manufacturing secrets, controlling access to advanced knowledge has long been a tool of social control. The modern museum system's handling of anomalous artifacts suggests this pattern continues in forms we're only beginning to recognize. Recent developments have begun to crack this wall of secrecy, though not through official channels. Digital photography has made unauthorized documentation easier despite restrictions. Leaked internal communications have revealed the scope of inter-institutional coordination around suppressing certain discoveries. Most significantly, a growing number of researchers have begun to speak openly about the pressure they face to avoid pursuing lines of inquiry that might challenge established chronologies. Their accounts paint a picture of academic institutions that have become guardians of approved narratives rather than centers of open inquiry. The existence of these hidden collections raises profound questions about the relationship between knowledge and power in contemporary society. If major institutions systematically suppress archaeological evidence that challenges conventional understanding of human technological development, what other discoveries might be hidden from public view? The answer to that question leads us deeper into collections that exist not in museum basements, but in the private archives of organizations whose influence extends far beyond the academic world. These repositories of forbidden knowledge contain more than just mysterious artifacts. Within their climate-controlled vaults rest documents, photographs, and research reports that trace patterns of technological suppression extending back centuries. The trail leads through medieval monasteries that hoarded classical texts, Renaissance workshops that guarded manufacturing secrets, and modern institutions that continue to control the flow of information about humanity's true technological heritage. Understanding this system requires examining not just what has been hidden, but who has been doing the hiding, and why they consider certain knowledge too dangerous for public consumption. The bronze fragments emerged from the seafloor coated in 2 millennia of marine growth, their true nature hidden beneath layers of coral and oxidation. For 71 years, they sat in storage at the National Archaeological Museum in Athens, dismissed as navigational instruments or decorative metalwork. Then, in 1971, physicist Derek de Solla Price convinced museum officials to let him examine the corroded lumps using X-ray photography. What those images revealed would fundamentally challenge everything historians thought they knew about ancient technological capabilities. The X-rays penetrated centuries of encrustation to expose an intricate mechanism of bronze gears, dials, and inscriptions that defied every assumption about what ancient Greeks could create. This wasn't a simple astrolabe or sundial. The device contained at least 37 meshing bronze gears arranged in a differential system that wouldn't be reinvented until clockmakers of the 16th century developed similar mechanisms. More disturbing still, the gear ratios precisely matched the orbital periods of celestial bodies with an accuracy that demanded astronomical observations spanning centuries. Price's initial analysis suggested the device could predict eclipses, track planetary positions, and calculate the dates of Olympic Games decades into the future. But as researchers developed increasingly sophisticated methods to peer inside the corroded mechanism, they discovered capabilities that pushed the boundaries of believability even further. The machine incorporated mechanical features that historians insisted weren't developed until the scientific revolution. Differential gears, epicyclic gear trains, and pointer mechanisms of extraordinary precision. The deeper researchers dug, the more impossible the device became. High-resolution CT scans revealed inscriptions referencing astronomical phenomena with mathematical precision that shouldn't have been achievable without telescopic observation. The gear teeth showed manufacturing tolerances requiring metalworking skills that archaeologists claim didn't exist until the industrial age. Most unsettling of all, certain calculations built into the mechanism demonstrated knowledge of celestial mechanics that wouldn't be formally discovered until Kepler's work in the early 17th century. Dr. Tony Freeth of University College London spent decades creating digital reconstructions of the complete mechanism. His team's analysis revealed that the device could model the irregular motion of the Moon with stunning accuracy, accounting for its elliptical orbit in ways that required understanding of complex mathematical relationships. This is more sophisticated than any known clockwork until well into the Renaissance, Freeth observed, though his published papers carefully avoided exploring the implications of that statement. The astronomical knowledge embedded in the mechanism presented equally troubling questions. The device incorporated what modern astronomy calls the Metonic cycle, a 19-year pattern that reconciles lunar and solar calendars with mathematical precision. While ancient astronomers are known to have observed this pattern, the mechanical implementation required engineering capabilities that exceeded anything else from the classical world. The bronze computer could also predict the 4-year cycle of Olympic Games and model the complex motions of the 5 planets visible to naked eye observation. But perhaps most disturbing was what researchers discovered about the device's origins. Initial assumptions placed its creation around the 1st century BC, making it an isolated anomaly in an otherwise primitive technological landscape. However, more detailed analysis of the inscriptions and astronomical data suggested the underlying knowledge might be much older. Some calculations built into the mechanism referenced astronomical observations that would have required centuries of systematic study to achieve. This implied not just one brilliant inventor, but an entire tradition of advanced astronomical and mechanical knowledge stretching back, potentially to the classical period of ancient Greece. The implications became even more unsettling when researchers attempted to trace the intellectual lineage of such sophisticated knowledge. Classical sources mention several figures who might have possessed the skills necessary to create such a device. Archimedes was known to have built planetariums and mechanical calculators, though no detailed descriptions of their internal workings survived. Hipparchus developed mathematical methods for predicting celestial motions that align closely with the calculations embedded in the mechanism. Apollonius of Perga created geometric models of planetary motion that provided the theoretical foundation for the device's mechanical implementation. Yet none of these historical figures left behind anything approaching the sophisticated engineering knowledge required to manufacture the bronze computer. The precision metalworking alone demanded skills that aren't documented anywhere in ancient technical literature. The gear cutting required tools and techniques that supposedly weren't developed until medieval clockmakers began creating mechanical timepieces. Most puzzling of all, the mathematical principles underlying the device's calculations weren't formally recognized by ancient mathematicians, according to surviving texts. This gap between the device's sophistication and the documented knowledge of its era has created profound discomfort within academic circles. Rather than acknowledge that ancient civilizations might have possessed capabilities far exceeding conventional estimates, many researchers have chosen to treat the mechanism as an isolated anomaly, a brilliant creation that somehow emerged without precedent and left no descendants. This interpretation requires believing that someone in the ancient world possessed knowledge and skills that wouldn't be matched again for over 1,000 years, then all traces of that knowledge vanished completely. The official response to these troubling implications has followed a predictable pattern. Initial excitement about the discovery gradually gave way to more cautious interpretations that emphasize the device's uniqueness rather than what it might represent about broader ancient capabilities. Academic papers began describing it as surprisingly sophisticated for its time, rather than acknowledging that its sophistication challenged fundamental assumptions about what was possible during its time. Conference presentations focused on technical details of the mechanism's operation while carefully avoiding broader questions about how such knowledge could have existed in the ancient world. More revealing still has been the treatment of researchers who've attempted to explore the device's implications for understanding ancient technological capabilities. Several promising lines of inquiry have been quietly discouraged through funding decisions and publication policies. Studies that might connect the mechanism to other anomalous artifacts from the same period have struggled to find academic support. Most tellingly, efforts to search for similar devices using modern archaeological techniques have been consistently underfunded, despite the revolutionary implications such discoveries might hold. The pattern of institutional resistance becomes clearer when examining how the mechanism's discovery has been presented to the public. Popular accounts emphasize its uniqueness and mystery while avoiding any suggestion that it might represent broader ancient capabilities. Educational materials describe it as an isolated example of ancient ingenuity rather than evidence of a lost technological tradition. Museum displays carefully frame the device as an exceptional creation that emerged from nowhere and led nowhere, rather than exploring what its existence might imply about the true extent of ancient knowledge. This careful management of public understanding extends beyond academic institutions into media coverage and popular science presentations. Documentary films about the mechanism invariably conclude with speculation about its mysterious creator, while avoiding questions about whether other similar devices might exist. Popular science articles focus on the technical ingenuity required to build such a machine, while sidestepping implications for our understanding of ancient technological development. Even fiction writers who've incorporated the device into their stories have been encouraged to treat it as a unique artifact, rather than exploring what it might represent about lost civilizations. The most disturbing aspect of this pattern isn't the suppression itself, but what it suggests about the scope of knowledge that might be hidden from public view. If a discovery as significant as the Antikythera mechanism can be quietly marginalized and its implications carefully contained, what other evidence of advanced ancient capabilities might be buried in museum collections or academic archives? The answer to that question requires looking beyond isolated artifacts to examine patterns of technological sophistication that appear throughout the ancient world. Recent developments in imaging technology have begun to reveal additional details about the mechanism that make its origins even more mysterious. Three-dimensional modeling has uncovered gear ratios that incorporate mathematical relationships not formally recognized until the development of modern celestial mechanics. Spectroscopic analysis has revealed bronze alloys with properties that suggest manufacturing techniques more sophisticated than anything else from the classical world. Most intriguingly, microscopic examination has uncovered tool marks that appear inconsistent with any known ancient metalworking methods. These discoveries have created new pressures for researchers studying the device. Access to the most sophisticated analytical equipment requires approvals that can take years to obtain. Publication of results that challenge conventional chronologies faces increasing scrutiny from peer reviewers, who question not the accuracy of findings, but their interpretation. Most significantly, funding for research that might connect the mechanism to other anomalous artifacts has become increasingly difficult to secure, as grant committees express preference for studies that treat it as an isolated phenomenon. The bronze computer's existence forces uncomfortable questions that extend far beyond ancient astronomy or metalworking. If sophisticated mechanical knowledge existed in the classical world, why do we have so few examples of it? Were there deliberate efforts to suppress or destroy such technologies? Did catastrophic events repeatedly eliminate accumulated knowledge? Or perhaps most unsettling of all, Has there been a continuous pattern throughout history of controlling access to advanced technologies to maintain existing power structures? These questions become even more troubling when examining other artifacts that display similar anomalous sophistication. Across the ancient world, archaeologists have uncovered evidence of technological capabilities that challenge conventional understanding of human development. From precision-cut stone blocks that require capabilities supposedly unavailable to ancient builders, to metallurgical achievements that surpass modern understanding, to optical devices that demonstrate knowledge of physics that wasn't formally recognized until centuries later. Each discovery, considered in isolation, can be dismissed as an anomaly or explained away through creative interpretation. But when examined together, they suggest a pattern of ancient technological sophistication that official histories have systematically minimized or ignored entirely. The bronze mechanism serves as a gateway into this hidden world of ancient capabilities, but it's far from the only key. Locked away in museum storage rooms and private collections around the world lie dozens of other artifacts that demonstrate similar technological sophistication. Their existence suggests that the classical world possessed knowledge and capabilities that have been deliberately erased from historical memory. Understanding why this knowledge was suppressed and by whom requires examining not just what was hidden, but the methods used to hide it. The trail leads through millennia of systematic destruction, from the burning of the Library of Alexandria to the suppression of classical texts during the early Christian period, to modern institutional policies that continue to shape what knowledge reaches public awareness. The Roman fleet stretched across Syracuse harbor like a forest of masts and bronze-reinforced hulls, confident in their overwhelming numerical advantage. General Marcus Claudius Marcellus had brought 220 ships and 8 legions to crush this single Greek city-state that dared defy Roman expansion. It was 214 BC, and Rome had never failed to conquer a besieged city. What happened next would haunt Roman military doctrine for centuries and create legends so disturbing that later historians would dismiss them as impossible exaggerations. The first ships burst into flames while still approaching the harbor walls. Roman marines watched in horror as focused beams of light, described by survivors as fire from heaven, ignited sails and tarred rigging from distances that made conventional incendiary weapons useless. Contemporary accounts describe how bronze mirrors mounted on the city walls concentrated sunlight into weapons of terrifying precision, capable of setting wooden vessels ablaze before they could reach archer range. Modern historians have spent centuries explaining why such weapons couldn't have existed, but recent experiments have proven that focused solar energy can indeed ignite ships under the right conditions. As the surviving Roman vessels pressed their attack, they encountered defenses that defied every principle of siege warfare known to the ancient world. Massive mechanical claws emerged from hidden positions along the harbor walls, seizing ships and lifting them entirely out of the water before dashing them against the rocks. These devices operated with precision that suggested sophisticated understanding of leverage, counterweights, and mechanical advantage. Roman engineers, masters of practical construction, found themselves helpless against technologies that exceeded anything in their considerable arsenal. The architect of these impossible defenses was Archimedes, remembered today primarily as the mathematician who supposedly ran naked through Syracuse shouting, "Eureka!" after discovering principles of water displacement. But contemporary Roman accounts paint a very different picture of this figure. To the legions besieging Syracuse, he wasn't an absent-minded scholar, but a military engineer whose weapons bordered on sorcery. Plutarch wrote that Roman soldiers became so terrified of his devices that if they saw a piece of rope or wood projecting above the wall, they cried that Archimedes was training some engine upon them and fled. The sophistication of these weapons becomes even more remarkable when examined through modern engineering analysis. The mechanical claws required precise calculation of forces, angles, and structural stresses that shouldn't have been possible without mathematical principles not formally recognized until the Renaissance. The mirror systems demanded understanding of optics and focal mathematics that allegedly wasn't developed until the scientific revolution. Most puzzling of all, the speed and coordination with which these weapons operated suggested mechanical automation that wouldn't be achieved again until the industrial age. Recent archaeological excavations beneath Syracuse have begun to reveal the physical evidence of this ancient arms factory. In 2008, ground-penetrating radar identified a network of underground chambers and tunnels that honeycombed the bedrock beneath the ancient city walls. When archaeologists finally gained access to these spaces, they discovered workshop areas containing tool marks and metal fragments that challenged every assumption about ancient manufacturing capabilities. The most disturbing discovery came in the form of bronze gear wheels and mechanical components that showed machine tool precision impossible to achieve with hand tools. Spectroscopic analysis revealed alloy compositions that required metallurgical knowledge supposedly unavailable to ancient civilizations. Most unsettling of all, the tool marks on these components matched patterns typically associated with mechanical cutting and shaping rather than traditional hammer and anvil metalworking. The implications suggested manufacturing capabilities that officially didn't exist for another 1,000 years. Dr. Alessandro Toretti, the lead archaeologist on the Syracuse excavation, initially approached these findings with appropriate scientific skepticism. His published reports carefully described the anomalous artifacts without drawing conclusions that might challenge established chronologies. But leaked correspondence between research team members tells a different story. Internal emails describe components that appear to have been manufactured using techniques inconsistent with known ancient capabilities, and metallurgical analysis that revealed properties that suggest advanced understanding of materials science. The workshop spaces themselves provided additional evidence of sophisticated engineering knowledge. Precision-cut stone channels suggested hydraulic systems for powering machinery. Bronze fittings showed wear patterns consistent with mechanical rotation and repetitive operation. Most significantly, the layout of the underground complex demonstrated understanding of workflow optimization and production efficiency that wouldn't be formally recognized as engineering principles until the industrial period. These weren't the crude workshops of ancient craftsmen, but precision manufacturing facilities designed for mass production of complex mechanical devices. The weapons described in Roman accounts begin to make sense when viewed in the context of such advanced manufacturing capabilities. The mechanical claws weren't simple lever systems, but sophisticated machines incorporating gear trains, pulleys, and counterweight mechanisms that multiplied human force to extraordinary degrees. The mirror weapons weren't just polished bronze sheets, but precisely engineered optical systems that focused and directed solar energy with mathematical precision. The catapults and ballistae that launched projectiles with impossible accuracy weren't crude siege engines, but precision instruments calibrated for specific targets and ranges. Contemporary Roman military manuals provide additional insight into the technological sophistication of these weapons. Detailed reports filed by Roman engineers describe defensive mechanisms that operated by principles unknown to our craftsmen, and siege engines that achieved accuracy beyond the capability of our finest artillery. These weren't vague descriptions of mysterious technologies, but technical assessments by professional military engineers who understood exactly how Roman weapons functioned and recognized that Syracuse's defenses operated according to different principles entirely. The systematic destruction that followed the city's eventual fall becomes more understandable when viewed in this context. After a siege that lasted nearly 3 years, extraordinarily long by Roman standards, Marcellus finally breached the walls through treachery rather than military superiority. His first orders involved not looting or enslaving the population, but the complete destruction of specific workshops and the seizure of particular individuals who possessed technical knowledge. Contemporary accounts describe how Roman soldiers were specifically instructed to burn certain buildings and documents while preserving others, suggesting a deliberate effort to eliminate specific types of knowledge. The fate of the technical personnel reveals the Romans' understanding of what they were dealing with. Rather than simply executing or enslaving the craftsmen responsible for the city's defenses, Marcellus had them transported to Rome under heavy guard. Imperial records suggest these individuals were housed in secured facilities and required to demonstrate their techniques for Roman engineers. However, the knowledge transfer appears to have been incomplete or deliberately sabotaged, as Roman weapons never achieved the sophistication displayed during the siege of Syracuse. What makes this pattern even more disturbing is how thoroughly the technical knowledge disappeared from historical record. Despite the Romans' systematic documentation of military technologies, detailed descriptions of Syracuse's weapons systems are notably absent from surviving technical manuals. Classical authors mention the weapons' effects, but provide little information about their construction or operation. Most tellingly, later Roman siege warfare shows no evidence of incorporating the principles or techniques that made Syracuse's defenses so effective, suggesting that the knowledge was either lost or deliberately suppressed. Modern efforts to reconstruct these ancient weapons have met with mixed success, largely because the mathematical and engineering principles underlying their operation weren't formally recognized until centuries after their original creation. Recent attempts to build working replicas of the mechanical claws have required incorporating gear ratios and leverage systems that demand understanding of mechanical engineering not officially developed until the Renaissance. The mirror weapons have proven equally challenging to recreate, as achieving the necessary optical precision requires manufacturing tolerances that test the limits of modern fabrication techniques. The institutional response to these archaeological findings has followed predictable patterns. Initial excitement about discovering Archimedes' workshop has given way to more cautious interpretations that emphasize the uncertain dating of the mechanical components and the possibility that later civilizations might have used the same underground spaces. Academic papers describing the excavation results focus on conventional artifacts like pottery and coins, while relegating discussion of anomalous mechanical devices to brief mentions in technical appendices. More revealing has been the treatment of researchers who've attempted to explore the engineering implications of the Syracuse discoveries. Funding for detailed analysis of the mechanical components has proven difficult to secure, with grant committees expressing preference for studies that focus on conventional archaeological questions. Publication of papers that emphasize the sophisticated nature of the discovered technologies has faced increased scrutiny from peer reviewers who question not the accuracy of findings, but their interpretation within established historical frameworks. The pattern of suppression extends beyond academic circles into public presentation of the discoveries. Museum exhibits about ancient Syracuse emphasize its cultural and political significance while minimizing discussion of military technologies. Popular documentaries about Archimedes focus on his mathematical discoveries while treating his engineering achievements as interesting curiosities rather than evidence of advanced capabilities. Educational materials describe the siege weapons as clever applications of simple principles rather than acknowledging their sophisticated engineering requirements. This careful management of public understanding becomes particularly troubling when examining what it conceals. If Archimedes possessed engineering knowledge centuries ahead of his time, and if that knowledge was systematically suppressed after Syracuse's fall, what does this suggest about other ancient technologies that might have suffered similar fates? The archaeological evidence from Syracuse represents just one example of ancient capabilities that challenge conventional understanding of technological development. Across the ancient world, other sites have yielded similar evidence of advanced engineering knowledge that disappeared without leaving traces in subsequent civilizations. The implications extend beyond questions of ancient technology into contemporary issues of knowledge control and institutional power. If major archaeological discoveries can be systematically marginalized and their significance minimized through academic and media channels, what other evidence of human capabilities might be hidden from public view? The methods used to suppress understanding of Syracuse's weapons systems mirror techniques employed to control information about other sensitive topics, suggesting that the suppression of ancient technological knowledge represents part of a much larger pattern of information management. The underground workshops of Syracuse hold secrets that go far beyond individual weapons or engineering techniques. They provide evidence of manufacturing capabilities, mathematical knowledge, and systematic approach to technological development that challenges fundamental assumptions about human progress, but they also reveal something equally disturbing about contemporary society: the existence of institutional mechanisms designed to prevent certain types of knowledge from reaching public awareness. Understanding these mechanisms requires examining not just what was hidden in ancient Syracuse, but how similar patterns of suppression continue to operate in the modern world. The crossbow bolt flew with mechanical precision, striking its target before the archer could even reach for another quarrel. But there was no archer. The weapon had loaded, aimed, and fired itself, part of a defensive system that transformed the approaches to ancient Chinese fortifications into killing fields operated by invisible hands. Contemporary accounts from the Warring States period describe crossbows that shot without human touch and siege engines that moved by their own will, technologies so advanced that later Chinese historians would dismiss them as poetic exaggeration rather than acknowledge their ancestors' impossible capabilities. In 2007, construction workers expanding a subway line beneath modern Xi'an broke through into a previously unknown section of the ancient imperial armory. What they discovered challenged everything archaeologists thought they knew about Chinese military technology. Buried beneath 2 millennia of urban development lay workshop spaces containing bronze mechanisms of extraordinary sophistication, including gear systems, trigger mechanisms, and loading devices that demonstrated automation principles not officially developed until the Industrial Revolution. The most remarkable discovery was a series of bronze crossbow mechanisms that incorporated automatic loading and firing systems. Each device contained intricate gear trains that used the energy from firing one bolt to cock the bowstring and position the next projectile. Chinese metallurgists had achieved precision manufacturing that allowed bronze components to mesh with tolerances measured in fractions of millimeters. The sophistication rivaled clockwork mechanisms from 18th century Europe. Yet these weapons were created during the 3rd century BC. Dr. Li Wei, the archaeologist tasked with cataloguing the armory discoveries, initially approached the mechanical weapons with appropriate skepticism. His preliminary reports described them as unusually sophisticated for their period, while avoiding conclusions that might challenge established chronologies. But as analysis progressed, the implications became impossible to ignore. These weren't crude mechanical devices, but precision instruments that demonstrated understanding of engineering principles that wouldn't be formally recognized for another 1,000 years. The automatic crossbows represented just one component of a much larger system of mechanized warfare. The underground workshops contained evidence of mass production techniques that challenged conventional understanding of ancient Chinese manufacturing. Standardized components suggested assembly line methods that created interchangeable parts for complex weapon systems. Tool marks on bronze components showed patterns consistent with mechanical cutting, rather than traditional hand forging. Most disturbing of all, the workshop layout demonstrated workflow optimization that incorporated principles of industrial engineering not formally developed until the modern era. Contemporary Chinese military treatises provide additional evidence of advanced automation technology. The Mozi, a text from the 5th century BC, describes defensive systems that operate without the need for human hands and siege engines that function by the power of their own design. The Art of War references weapons that strike without warning and fortifications that defend themselves against all assault. While modern scholars have traditionally interpreted these passages as metaphorical language, the archaeological evidence suggests they may have been literal descriptions of actual technologies. The sophistication becomes even more remarkable when examining the mathematical principles underlying these automated systems. Chinese engineers had developed gear ratios that multiplied force with extraordinary efficiency, allowing human operators to cock massive crossbows through mechanical advantage systems that reduced the required effort by factors of 10 or more. The timing mechanisms that controlled automatic firing incorporated escapement principles that wouldn't be rediscovered until medieval clockmakers began creating mechanical timepieces. Most impressively, some devices included feedback systems that adjusted their operation based on external conditions, demonstrating understanding of cybernetic principles not formally recognized until the 20th century. Recent analysis using advanced imaging techniques has revealed additional details that make the Chinese automation technology even more mysterious. Three-dimensional scanning has uncovered internal mechanisms with complexity that rivals modern mechanical systems. Spectroscopic analysis has identified bronze alloys with properties that suggest metallurgical knowledge superior to anything else from the ancient world. Most puzzling of all, microscopic examination has revealed manufacturing techniques that appear inconsistent with any known ancient metalworking methods. The weapon's operational capabilities, as described in contemporary sources, pushed the boundaries of what seemed possible with pre-industrial technology. Automatic crossbows could allegedly fire 60 bolts per minute without human intervention, a rate of fire that wouldn't be matched by firearms until the development of rapid-fire weapons in the 19th century. Siege engines could launch projectiles with accuracy that exceeded anything achieved by Roman artillery, suggesting guidance systems that incorporated principles of ballistic calculation not formally developed until the scientific revolution. The systematic destruction that followed certain military defeats becomes more understandable when viewed in the context of such advanced technology. Historical records describe how conquering armies would specifically target workshops and technical personnel, suggesting recognition that these represented strategic assets more valuable than conventional military equipment. The burning of technical libraries and the execution of master craftsmen followed patterns that indicated deliberate efforts to prevent technological knowledge from falling into enemy hands. What makes the Chinese automation technology particularly disturbing is how completely it disappeared from subsequent military development. Despite China's reputation for preserving classical knowledge, detailed technical descriptions of these automated weapons are notably absent from later military manuals. The sophisticated manufacturing techniques that created interchangeable parts and precision mechanisms vanished so thoroughly that Chinese weapons technology actually regressed for centuries after their initial development. This pattern suggests not gradual loss through natural causes, but systematic suppression of specific types of knowledge. The institutional response to these Xi'an discoveries has followed predictable patterns of minimization and containment. Initial media coverage emphasized the historical significance of discovering new ancient armory sites while carefully avoiding detailed discussion of the technological sophistication involved. Academic papers describing the excavation results focus on conventional artifacts like pottery and coins, while relegating the mechanical devices to brief mentions in technical appendices. Most tellingly, public access to the discovery site has been severely restricted, with only a small number of pre-approved researchers allowed to examine the automated weapons. International efforts to study the Chinese automation technology have met with systematic obstruction through bureaucratic channels. Foreign researchers seeking access to the Xi'an artifacts face approval processes that can stretch for years, often ending in rejection for vaguely defined security reasons. Collaborative research proposals that might connect the Chinese discoveries to similar technologies from other ancient civilizations have been consistently denied funding by institutions that express preference for studies treating each culture's achievements in isolation. The pattern of suppression extends beyond academic circles into popular presentation of Chinese military history. Museum exhibits about ancient Chinese warfare emphasize conventional weapons like swords and spears, while minimizing discussion of automated systems. Educational materials describe Chinese military innovations as clever applications of simple principles rather than acknowledging their sophisticated engineering requirements. Even documentaries about ancient Chinese technology focus on more familiar inventions like gunpowder and printing, while avoiding topics that might challenge conventional understanding of technological development. This careful management of information becomes particularly troubling when examining what contemporary Chinese sources suggest about the scope of automation technology. References in classical texts indicate that automated weapons represented just one application of broader mechanical principles that extended into civilian applications. Descriptions of automated farming equipment, mechanical transportation systems, and even robotic servants suggest that Chinese engineers had developed a comprehensive understanding of automation that permeated multiple aspects of society. The implications for understanding ancient technological capabilities become even more disturbing when considering the geographic scope of similar discoveries. Archaeological sites across East Asia have yielded evidence of mechanical sophistication that mirrors the Xi'an findings, suggesting that automated technology represented a widespread achievement rather than isolated innovation. Bronze mechanisms from Korea demonstrate similar precision manufacturing. Japanese archaeological sites have produced gear systems that incorporate identical mathematical principles. Vietnamese excavations have uncovered weapons systems that show clear technological relationships to the Chinese automation technology. This geographic distribution raises uncomfortable questions about the nature of ancient technological development. If multiple East Asian civilizations possessed automation capabilities that exceeded anything achieved in the West until the Industrial Revolution, why did this knowledge disappear so completely? Were there coordinated efforts to suppress advanced technology across multiple cultures? Did catastrophic events repeatedly destroy accumulated knowledge? Or perhaps most unsettling of all, has there been a continuous pattern throughout history of controlling access to advanced technologies to maintain existing power structures. The Chinese automation technology represents more than just sophisticated weapons or clever engineering solutions. It provides evidence of manufacturing capabilities, mathematical knowledge, and systematic approach to mechanical design that challenges fundamental assumptions about the progression of human technological development. The precision required to create interchangeable parts, the mathematical sophistication needed to design gear ratios, and the engineering knowledge necessary to achieve reliable automation all suggest capabilities that shouldn't have existed for another millennium. Recent developments in artificial intelligence and robotics have provided new perspectives on the Chinese automation achievements that make them even more remarkable. Modern engineers attempting to recreate the ancient automated crossbows have discovered that achieving reliable mechanical automation without electronic controls requires understanding of feedback systems and mechanical logic that tests the limits of current knowledge. The realization that Chinese engineers solved these problems using only Bronze Age materials and hand tools has created profound respect among contemporary robotics specialists for the sophistication of ancient achievements. The underground workshops of Xi'an hold secrets that extend far beyond individual weapons or mechanical curiosities. They provide evidence of industrial capabilities, systematic innovation, and technological integration that suggests ancient Chinese civilization achieved levels of automation that wouldn't be matched again until the modern era. But they also reveal something equally significant about contemporary information control: the existence of institutional mechanisms designed to prevent certain types of knowledge from challenging established historical narratives. Understanding these mechanisms requires examining not just what was achieved in ancient China, but how similar patterns of technological suppression continue to operate across other ancient civilizations that may have possessed capabilities equally challenging to conventional understanding. The sword blade gleamed with patterns that seemed to flow like water frozen in metal, its surface displaying ripples and waves that had mesmerized warriors and craftsmen for over 1,000 years. Damascus steel represented the pinnacle of medieval metallurgy, creating weapons so superior to European swords that Crusader knights would abandon their own blades to wield captured Eastern weapons. But when modern metallurgists finally gained access to authentic Damascus steel specimens in the 1970s, what they discovered challenged everything science understood about what was possible with pre-industrial metalworking. Dr. Verhoeven of Iowa State University spent decades analyzing fragments of genuine Damascus steel using electron microscopy and spectroscopic techniques unavailable to earlier researchers. What his team found embedded within the metal's crystalline structure defied explanation. The steel contained carbon nanotubes, cylindrical arrangements of carbon atoms that modern materials science considers one of the most advanced achievements of contemporary nanotechnology. These microscopic structures, invisible to naked eye observation, provided the exceptional strength and flexibility that made Damascus weapons legendary throughout the medieval world. The implications were staggering. Carbon nanotubes weren't officially discovered until 1991, when Japanese physicist Sumio Iijima first observed them using advanced electron microscopy. The idea that medieval blacksmiths could create materials containing nanostructures that modern science struggles to produce reliably seemed impossible. Yet there they were, embedded within steel forged in workshops that lacked electricity, precision temperature control, or any of the sophisticated equipment that contemporary materials engineers consider essential for nanotechnology. The manufacturing process that created these impossible materials becomes even more mysterious when examined in detail. Damascus steel required techniques that medieval sources describe only in the most cryptic terms, using language that modern metallurgists interpret as deliberate obfuscation. References to water of life, fire of the earth, and breath of the dragon may have been poetic metaphors, or they might have encoded specific technical procedures that blacksmiths were forbidden to describe directly. Contemporary accounts suggest that master steelmakers guarded their knowledge so carefully that they would destroy their workshops rather than reveal their secrets to unauthorized individuals. The geographic origins of this technology create additional mysteries that challenge conventional understanding of medieval trade and knowledge transfer. Authentic Damascus steel was produced primarily in regions around modern-day Syria and Iran, using iron ore sources that contained specific impurities crucial to the final product's properties. However, recent analysis has revealed that achieving the documented quality required not just particular raw materials, but manufacturing techniques that demanded understanding of metallurgical principles not formally recognized until the Industrial Revolution. Archaeological evidence from medieval Damascus workshops provides tantalizing clues about the sophistication of ancient steel-making operations. Excavations have uncovered furnace designs that achieve temperatures and atmospheric conditions precisely calibrated for creating complex steel alloys. Tool marks on recovered equipment suggest manufacturing tolerances that required mechanical precision exceeding anything else from the medieval period. Most puzzling of all, chemical analysis of workshop residues has revealed trace elements that indicate processes involving materials and techniques that shouldn't have been available to medieval craftsmen. The systematic loss of Damascus steel technology represents one of history's most documented cases of advanced knowledge disappearing despite its obvious value. Production began declining in the 18th century, not due to lack of demand but because master craftsmen were dying without successfully transmitting their techniques to apprentices. Contemporary accounts describe how the most skilled steelmakers would rather destroy their workshops than risk their knowledge falling into the wrong hands. By the mid-19th century, the ability to produce authentic Damascus steel had vanished entirely, despite numerous attempts by European metallurgists to reverse engineer the process. Modern efforts to recreate Damascus steel have achieved mixed success, largely because contemporary materials science approaches the problem from fundamentally different directions than medieval craftsmen. Industrial steel production relies on precise chemical composition and controlled environmental conditions to achieve desired properties. Medieval Damascus steel makers appear to have used entirely different principles, incorporating what modern science would recognize as chaos theory and complex systems dynamics to create materials with properties that emerged from the manufacturing process itself, rather than being designed into it. The institutional response to discoveries about Damascus steel's nanotechnology has followed predictable patterns of minimization and alternative explanation. Rather than acknowledge that medieval craftsmen achieved materials science breakthroughs that modern technology struggles to replicate, academic papers emphasize the accidental nature of carbon nanotube formation. The official interpretation suggests that medieval blacksmiths unknowingly created advanced materials through processes they didn't understand, rather than considering the possibility that they possess knowledge that has subsequently been lost. This interpretation becomes problematic when examining the consistency with which Damascus steel achieved its exceptional properties. Accidental processes typically produce variable results, but authentic Damascus weapons display remarkably uniform characteristics that suggest systematic understanding rather than fortunate coincidence. The precision required to consistently create materials containing carbon nanotubes indicates that medieval craftsmen understood exactly what they were doing, even if they described their knowledge using different terminology than modern science employs. Recent developments in materials science have provided new perspectives on the Damascus steel achievements that make them even more remarkable. Contemporary researchers attempting to produce carbon nanotube-enhanced steel using modern equipment have discovered that achieving the structural properties documented in medieval weapons requires understanding of quantum mechanics and molecular chemistry that challenges current scientific knowledge. The realization that medieval craftsmen solved these problems using only traditional metalworking tools has created profound respect among materials scientists for the sophistication of ancient metallurgical knowledge. The pattern of knowledge suppression around Damascus steel extends beyond academic minimization into active prevention of research that might challenge conventional historical narratives. Studies that attempt to connect Damascus steel techniques to other advanced ancient metallurgical achievements have struggled to find funding or publication venues. International cooperation between researchers studying anomalous ancient materials has been systematically discouraged through bureaucratic obstacles and institutional policies that favor treating each discovery in isolation. The geographic distribution of advanced ancient metallurgy raises additional questions about the scope of lost technological knowledge. Archaeological sites across the ancient world have yielded evidence of metalworking sophistication that rivals or exceeds Damascus steel achievements. Roman concrete contains nanostructures that provide self-healing properties superior to modern materials. Indian iron pillars display corrosion resistance that contemporary metallurgy cannot fully explain. Japanese sword-making techniques achieved edge retention that modern steel cannot match despite centuries of technological advancement. This global pattern of metallurgical sophistication suggests that advanced materials science represented a widespread achievement of ancient civilizations rather than isolated innovation in medieval Damascus. The systematic loss of these technologies across multiple cultures indicates coordinated suppression rather than natural decline through neglect or catastrophe. Understanding who orchestrated this suppression and why they considered advanced metallurgy too dangerous for public knowledge requires examining the social and political contexts within which these technologies operated. Medieval sources provide disturbing hints about the relationship between advanced metallurgy and political power. References in contemporary chronicles suggest that certain metalworking knowledge was considered state secrets that could determine the outcome of military conflicts. Guild records indicate that master craftsmen operated under oath of secrecy that extended beyond normal trade protection to include provisions resembling modern national security classifications. Most tellingly, historical accounts describe how conquering armies would specifically target workshops and technical personnel, suggesting recognition that metallurgical knowledge represented strategic assets more valuable than conventional military equipment. The deliberate destruction of Damascus steel knowledge becomes even more suspicious when examined alongside similar patterns of technological suppression throughout history. The burning of the Library of Alexandria eliminated countless technical treatises that might have preserved ancient metallurgical secrets. The suppression of classical learning during the early Christian period specifically targeted practical knowledge that was deemed dangerous to established authority. The systematic destruction of Islamic scientific works during the Reconquista eliminated entire traditions of advanced materials science that had preserved and extended ancient knowledge. Contemporary efforts to reconstruct lost metallurgical techniques face obstacles that extend beyond technical challenges into institutional resistance. Research proposals that attempt to connect Damascus steel to other advanced ancient materials encounter peer review processes that consistently question not the accuracy of findings, but their interpretation within established historical frameworks. Funding for studies that might demonstrate the sophistication of ancient metallurgy has become increasingly difficult to secure. as grant committees express preference for projects that treat historical achievements as primitive precursors to modern technology, rather than acknowledging that ancient craftsmen might have possessed knowledge that surpasses contemporary capabilities. The carbon nanotubes embedded within Damascus steel represent more than just sophisticated materials, science, or clever metalworking techniques. They provide evidence of knowledge systems that operated according to principles fundamentally different from modern scientific approaches, yet achieved results that contemporary technology struggles to replicate. The precision required to consistently create these nanostructures, the understanding necessary to optimize their properties, and the systematic approach needed to integrate them into practical applications all suggest capabilities that challenge fundamental assumptions about the progression of human technological development. The steel that can't be made reveals secrets that extend far beyond individual weapons or metallurgical curiosities. It demonstrates manufacturing capabilities, scientific knowledge, and systematic innovation that suggest ancient civilizations achieved levels of materials science that wouldn't be formally recognized again until the modern era. But it also exposes something equally significant about contemporary knowledge control. The existence of institutional mechanisms designed to prevent certain types of technological achievements from challenging established narratives about human progress. These mechanisms operate not just in academic circles but extend into industrial research, where the implications of ancient materials science might threaten existing commercial interests and technological paradigms. The obsidian blade caught the morning light like captured fire, its edge so sharp that even gentle pressure could slice through human skin without sensation. Mayan warriors called these weapons teeth of the gods, and for good reason. The volcanic glass could be knapped to create cutting edges just 3 nanometers thick, sharper than modern surgical scalpels and capable of maintaining their precision through countless battles. But when contemporary archaeologists began studying Mayan obsidian technology using electron microscopy, they discovered something that challenged everything they thought they knew about pre-Columbian manufacturing capabilities. The workshop spaces beneath Chichen Itza revealed evidence of mass production techniques that shouldn't have been possible without industrial equipment. Thousands of obsidian cores showed identical preparation marks, suggesting standardized procedures that created interchangeable components for weapon assembly. Tool marks on finished blades displayed patterns consistent with mechanical cutting rather than traditional knapping techniques. Most disturbing of all, microscopic analysis revealed that Mayan craftsmen had achieved optical precision in their blade geometry, creating weapons with edge angles calculated to optimize cutting efficiency according to principles not formally recognized until modern materials science. Dr. Maria Gonzalez led the team that first documented these anomalous manufacturing signatures in 2011. Her initial reaction was skepticism. The precision suggested by the archaeological evidence seemed impossible to achieve using Stone Age technology. But as analysis progressed, the implications became undeniable. Mayan obsidian workers had developed techniques that required understanding of crystal lattice structures, optical physics, and precision manufacturing that exceeded anything else from the pre-Columbian world. The sophistication becomes even more remarkable when examining the optical devices that Mayan craftsmen created using identical techniques. Archaeological sites across the Yucatan have yielded obsidian mirrors with curvatures precisely calculated to focus light at specific distances. These weren't crude, reflective surfaces, but sophisticated optical instruments that demonstrated understanding of geometric optics and wave behavior. Recent analysis has revealed that some mirrors incorporated compound curves that corrected for spherical aberration, a technical achievement that European lens makers wouldn't accomplish until the 17th century. Contemporary Mayan codices provide additional evidence of advanced optical knowledge that archaeological discoveries are only now beginning to confirm. References to seeing stones that could bring distant objects near may have described telescopic devices using obsidian optics. Descriptions of fire mirrors that could summon the sun's power align with recent discoveries of parabolic obsidian reflectors designed to concentrate solar energy. Most intriguingly, accounts of truth crystals that could reveal hidden knowledge might refer to optical instruments used for precision measurement and astronomical observation. The manufacturing processes required to create such sophisticated optical devices challenge every assumption about Mayan technological capabilities. Achieving the documented precision demanded understanding of mathematical principles that weren't formally recognized until the scientific revolution. The quality control necessary to mass-produce interchangeable components suggested industrial organization that wouldn't be achieved in Europe until the 18th century. Most puzzling of all, the consistency of results across multiple production sites indicated standardized procedures that required systematic knowledge transfer across the entire Mayan civilization. Recent excavations at previously unexplored Mayan sites have uncovered additional evidence of advanced manufacturing capabilities that extend far beyond obsidian working. Workshop areas contain bronze tools with cutting edges that show wear patterns consistent with precision machining rather than hand fabrication. Stone-cutting implements display geometric accuracy that requires understanding of engineering principles not officially developed until the Renaissance. Most significantly, the workshop layouts demonstrate workflow optimization that incorporated principles of industrial efficiency not formally recognized until the modern era. The systematic destruction that followed Spanish conquest becomes more understandable when viewed in the context of such advanced technology. Contemporary accounts describe how conquistadors specifically targeted workshops and technical personnel, suggesting recognition that these represented strategic assets more valuable than gold or silver. The burning of Mayan codices eliminated not just historical records, but technical documentation that might have preserved advanced manufacturing knowledge. Diego de Landa's infamous Auto da Fe in 1562 may have destroyed the last comprehensive records of optical and precision manufacturing techniques that took centuries to redevelop. What makes the Mayan achievements particularly disturbing is how completely they disappeared from subsequent Mesoamerican development. Despite continuous occupation of many Mayan sites, the sophisticated manufacturing techniques vanished so thoroughly that later indigenous peoples created weapons using much cruder methods. The precision optics that had enabled accurate astronomical observation were replaced by simple reflective surfaces with no focusing capability. The mass production techniques that had created standardized tools and weapons gave way to individual craftsmanship that couldn't match earlier quality standards. The institutional response to discoveries about Mayan manufacturing's sophistication has followed predictable patterns of minimization and alternative explanation. Rather than acknowledge that pre-Columbian civilizations achieved precision manufacturing and optical technology that exceeded European capabilities, academic papers emphasize the limited scope of these achievements. The official interpretation suggests that Mayan craftsmen developed sophisticated techniques through trial and error rather than systematic understanding, despite archaeological evidence that indicates exactly the opposite. This interpretation becomes problematic when examining the mathematical precision required to create the documented optical devices. Accidental napping cannot produce parabolic curves calculated to specific focal lengths. Random experimentation doesn't yield consistent edge geometries optimized for cutting efficiency. The systematic approach evident in Mayan manufacturing suggests not just technical skill, but theoretical knowledge that guided practical application according to principles that modern science has only recently begun to understand. Recent developments in nanotechnology and precision manufacturing have provided new perspectives on the Mayan achievements that make them even more remarkable. Contemporary researchers attempting to replicate Mayan obsidian blades using modern equipment have discovered that achieving the documented edge sharpness requires understanding of crystal fracture mechanics that challenges current materials science. The realization that Mayan craftsmen solved these problems using only Stone Age tools has created profound respect among modern engineers for the sophistication of ancient manufacturing knowledge. The pattern of knowledge suppression around Mayan technology extends beyond academic minimization into active prevention of research that might challenge conventional understanding of pre-Columbian capabilities. Studies that attempt to connect Mayan manufacturing techniques to other advanced ancient technologies have struggled to find funding or publication venues. International cooperation between researchers studying anomalous Mesoamerican achievements has been systematically discouraged through bureaucratic obstacles and institutional policies that favor treating each culture's accomplishments in isolation. The broader context of Indian technical literature reveals knowledge systems that extended far beyond metallurgy into multiple areas of advanced technology. Sanskrit texts describe engineering principles, chemical processes, and mathematical concepts that weren't formally recognized in European science until centuries later. The Samarangana Sutradhara contains descriptions of mechanical devices that incorporate principles of automation and feedback control. The Rasanava describes chemical processes that align with modern understanding of advanced material synthesis. The Yukti Kalpataru provides engineering specifications that require mathematical knowledge exceeding anything available in contemporary European technical literature. This comprehensive scope of technical knowledge suggests that ancient Indian civilization possessed integrated understanding of multiple scientific disciplines that operated according to different principles than European approaches, but achieved results that contemporary technology often cannot match. The systematic suppression of these knowledge systems during the colonial period eliminated not just individual techniques, but entire scientific paradigms that might have provided alternative approaches to technological development. Contemporary efforts to reconstruct lost Indian metallurgical techniques face obstacles that extend beyond technical challenges into institutional resistance rooted in colonial-era attitudes about indigenous knowledge. Research proposals that attempt to demonstrate the sophistication of ancient Indian technology encounter peer review processes that consistently question not the accuracy of findings, but their interpretation within established historical frameworks. Funding for studies that might reveal the advanced nature of Indian achievements has become increasingly difficult to secure, as grant committees express preference for projects that treat indigenous accomplishments as primitive precursors to European technology. The iron that cannot rust represents more than just sophisticated metallurgy or clever metalworking techniques. It provides evidence of knowledge systems that operated according to principles fundamentally different from European scientific approaches, yet achieved results that contemporary materials science struggles to replicate. The precision required to consistently create corrosion-resistant alloys, the understanding necessary to optimize material properties, and the systematic approach needed to integrate multiple technical disciplines all suggest capabilities that challenge fundamental assumptions about the progression of human technological development. The impossible iron of India reveals secrets that extend far beyond individual artifacts or metallurgical curiosities. It demonstrates scientific capabilities, systematic innovation, and integrated knowledge systems that suggest ancient Indian civilization achieved levels of materials science that wouldn't be formally recognized in European science until the modern era. But it also exposes something equally significant about colonial and post-colonial knowledge control: the the existence of mechanisms designed to prevent indigenous achievements from challenging established narratives about European technological superiority. These mechanisms continue to operate in contemporary academic institutions, where acknowledgement of advanced ancient Indian capabilities might threaten established interpretations of scientific development and cultural hierarchy that trace their origins to colonial-era suppression of indigenous knowledge systems. The liquid fire clung to wood and water alike, burning with an intensity that transformed the Golden Horn into a cauldron of destruction. Arab ships that had sailed confidently toward Constantinople's walls found themselves engulfed in flames that seawater couldn't extinguish and wind couldn't blow away. Byzantine defenders watched from the city's ramparts as enemy vessels became floating pyres, their crews leaping into waters that offered no refuge from the mysterious substance that burned even on the surface of the sea. The year was 678 AD, and the world had just witnessed the debut of history's most terrifying chemical weapon: Greek fire. The formula for this liquid inferno represented one of Byzantium's most closely guarded state secrets, protected by security measures that exceeded those surrounding modern nuclear weapons. Contemporary sources describe how knowledge of its composition was restricted to a handful of imperial craftsmen who worked in isolated facilities under constant surveillance. The manufacturing process involved multiple stages conducted at separate locations, ensuring that no single individual possessed complete knowledge of the formula. Even the emperor's closest advisors knew only that the substance existed, not how it was created or what ingredients it contained. Modern attempts to reverse engineer Greek fire have failed to replicate its documented properties, despite access to sophisticated chemical analysis and synthetic techniques unavailable to Byzantine chemists. The substance burned on water, adhered to targets like napalm, and couldn't be extinguished by conventional means, characteristics that require chemical properties that contemporary science struggles to achieve using medieval materials and methods. Most puzzling of all, contemporary accounts describe variants of the formula that produce different effects. Some versions created smoke screens that blinded enemies, others generated intense heat without visible flames, and still others produced explosions that shattered stone fortifications. Dr. Holden of Princeton University has spent decades studying Byzantine military technology, with particular focus on the chemical weapons that gave Constantinople its decisive advantage over Arab naval forces. His analysis of contemporary sources reveals descriptions of manufacturing processes that require understanding of chemistry principles not formally recognized until the scientific revolution. References to naphtha that burns without consuming itself and sulfur that creates thunder without lightning suggest chemical reactions involving compounds that shouldn't have been available to medieval alchemists using documented techniques. The sophistication becomes even more remarkable when examining the delivery systems that Byzantine engineers developed for deploying their chemical weapons. Archaeological evidence from Constantinople's harbour fortifications reveals bronze siphons with internal mechanisms that achieved pressure and flow rates impossible to generate using simple pumps. The weapons incorporated mixing chambers that combined multiple chemical components at the moment of discharge, suggesting understanding of controlled chemical reactions that wasn't formally developed until much later periods. Most impressively, some devices included timing mechanisms that delayed ignition until projectiles reached their targets, demonstrating knowledge of chemical delays and controlled combustion. Contemporary Byzantine technical manuals provide additional evidence of advanced chemical knowledge that archaeological discoveries are only now beginning to confirm. The Parangulmata Poliorcetica describes weapons manufacturing techniques that incorporate principles of quality control and standardization that required systematic understanding of chemical processes. References to waters that dissolve stone may describe acid formulations with capabilities that medieval chemistry supposedly couldn't achieve. Most intriguingly, accounts of defensive systems that created walls of fire might refer to area denial weapons that contemporary military technology has only recently begun to develop. The systematic destruction of Greek fire knowledge following Constantinople's fall represents one of history's most complete examples of technological suppression for strategic purposes. When Ottoman forces finally breached the city's walls in 1453, their first priority involved not looting treasures, but locating and destroying the workshops where chemical weapons were manufactured. Contemporary accounts describe how Ottoman soldiers specifically targeted technical personnel and burned facilities that contained chemical knowledge, suggesting recognition that these represented strategic assets more valuable than conventional military equipment. The institutional secrecy surrounding Greek fire extended beyond military applications into the broader Byzantine approach to managing dangerous knowledge. Imperial policies treated certain types of chemical information as state secrets that warranted execution for unauthorized disclosure. Guild records indicate that craftsmen working with advanced chemical processes operated under oath of secrecy that included provisions resembling modern national security classifications. Most tellingly, Byzantine law specifically criminalized the teaching of certain chemical techniques to foreigners, suggesting systematic effort to prevent technological knowledge from spreading beyond imperial control. What makes the Greek fire mystery particularly disturbing is how completely the chemical knowledge disappeared despite its obvious military value. Following the fall of Constantinople, attempts by various European powers to recreate the legendary liquid fire achieved only limited success, producing incendiary mixtures that lacked the documented properties of the original formula. The precision chemistry that had enabled Byzantine engineers to create weapons with specific performance characteristics vanished so thoroughly that later chemical warfare development had to begin from entirely different principles. Recent analysis using advanced chemical techniques has revealed additional details about Greek fire that make its medieval origins even more mysterious. Residue samples from Byzantine harbour excavations contain chemical signatures that suggest reaction mechanisms involving compounds not formally identified until modern chemistry. Spectroscopic analysis has revealed trace elements that indicate manufacturing processes requiring materials and techniques that shouldn't have been available to medieval chemists. Most puzzling of all, microscopic examination has uncovered evidence of controlled molecular arrangements that appear inconsistent with any known ancient chemical methods. The pattern of knowledge suppression around Byzantine chemical weapons extends beyond military secrecy into broader questions about the relationship between advanced technology and political power throughout history. The systematic destruction of Greek fire knowledge mirrors patterns of technological suppression that appear across multiple civilizations and time periods, suggesting coordinated effort to prevent certain types of capabilities from spreading beyond authorized control. Understanding who orchestrated these suppressions and why they considered chemical warfare technology too dangerous for widespread knowledge requires examining the social and political contexts within which these technologies operated. Medieval sources provide disturbing hints about international cooperation in suppressing advanced chemical knowledge. Diplomatic correspondence between Byzantine, Islamic, and European courts suggests that certain technologies were considered mutually threatening, regardless of political boundaries. Treaty negotiations included provisions that specifically addressed the non-proliferation of chemical warfare techniques, indicating recognition that these weapons posed threats that transcended conventional military concerns. Most significantly, papal records describe how certain types of chemical knowledge were classified as heretical sciences that warranted suppression through religious authority as well as political force. The deliberate destruction of chemical warfare knowledge becomes even more suspicious when examined alongside similar patterns of technological suppression that appear throughout the medieval period. The systematic elimination of classical chemical texts during the early Christian period removed much of the theoretical foundation that had supported advanced chemical practices. The persecution of alchemists and chemical practitioners eliminated the intellectual infrastructure necessary for preserving and developing sophisticated chemical knowledge. The institutional preference for limiting chemical education to narrow religious contexts prevented the systematic study that might have preserved dangerous capabilities. Contemporary efforts to understand lost chemical warfare techniques face obstacles that extend beyond technical challenges into institutional resistance rooted in concerns about modern security implications. Research proposals that attempt to reverse engineer historical chemical weapons encounter review processes that question not just the accuracy of findings, but the wisdom of pursuing lines of inquiry that might recreate dangerous capabilities. Funding for studies that might reveal the sophisticated nature of ancient chemical achievements has become increasingly difficult to secure, as grant committees express concern about the potential applications of such knowledge. The institutional response to discoveries about Byzantine chemical sophistication has followed predictable patterns of minimization and alternative explanation. Rather than acknowledge that medieval chemists achieved reaction control and compound synthesis that contemporary science struggles to replicate, academic papers emphasize the limited scope of ancient achievements and the primitive nature of medieval understanding. The official interpretation suggests that Byzantine chemical weapons resulted from accidental discoveries rather than systematic knowledge, despite historical evidence that indicates exactly the opposite. This interpretation becomes problematic when examining the precision with which Greek fire achieved its documented military effects. Accidental chemical discoveries typically produce unpredictable results, but Greek fire demonstrated consistent performance characteristics that suggest systematic understanding of underlying reaction mechanisms. The ability to create variants with different properties indicates that Byzantine chemists possess theoretical knowledge that guided practical applications according to specific military requirements rather than random experimentation. Recent developments in chemical warfare defense have provided new perspectives on the Byzantine achievements that make them even more remarkable. Contemporary researchers attempting to create countermeasures for modern incendiary weapons have discovered that achieving the performance characteristics documented for Greek fire requires understanding of reaction chemistry and materials science that challenges current knowledge. The realization that medieval chemists solved these problems using only traditional laboratory techniques has created profound concern among military analysts about the implications of lost chemical knowledge. The geographic scope of advanced chemical warfare technology raises additional questions about the extent of medieval knowledge systems that have been deliberately suppressed. Archaeological sites throughout the medieval world have yielded evidence of chemical sophistication that rivals Byzantine achievements. Islamic alchemical texts describe reaction procedures that demonstrate understanding of chemistry principles centuries ahead of their time. Chinese military manuals reference chemical weapons with capabilities that exceeded anything available in contemporary Europe. European monastery records contain chemical formulas that suggest knowledge of synthesis techniques not officially developed until the modern era. This global pattern of chemical sophistication suggests that advanced chemical knowledge represented a widespread achievement of medieval civilization rather than isolated innovation in Byzantine Constantinople. The systematic loss of these technologies across multiple cultures indicates coordinated suppression rather than natural decline through neglect or catastrophe. Understanding who orchestrated this suppression and why they considered chemical knowledge too dangerous for preservation requires examining the institutional mechanisms that continue to control access to sensitive technical information. The liquid fire that burned on water reveals secrets that extend far beyond individual weapons or chemical curiosities. It demonstrates reaction control, synthetic capabilities, and systematic innovation that suggest medieval civilization achieved levels of chemical science that wouldn't be formally recognized again until the modern era. But it also exposes something equally significant about the relationship between knowledge and power throughout history. The existence of mechanisms designed to prevent certain types of technological capabilities from challenging established authority structures. These mechanisms operate not just in military contexts, but extend into academic and industrial institutions, where the implications of advanced chemical knowledge continue to raise questions about the wisdom of preserving dangerous capabilities versus the cost of suppressing human achievement. The smoke from burning manuscripts darkened the Mediterranean sky for 3 days in 391 AD, as Christian mobs systematically destroyed the Serapeum of Alexandria under orders from Patriarch Theophilus. Among the scrolls that fed those flames were technical treatises on mechanical engineering, metallurgy, optics, and chemical processes that represented centuries of accumulated knowledge from across the ancient world. Contemporary witnesses described how certain texts were specifically targeted for destruction, not random acts of religious fervor, but calculated elimination of particular types of dangerous knowledge that church authorities deemed incompatible with the new Christian order. This wasn't the first time advanced technical knowledge had been systematically erased from human memory, nor would it be the last. Across the centuries, a pattern emerges of coordinated efforts to suppress technologies that threatened existing power structures or challenged established narratives about human capabilities. From the burning of Baghdad's House of Wisdom in 1258 AD to the systematic destruction of Aztec codices in 20th century Mexico, the same methods appear repeatedly. Target the libraries, eliminate the technical personnel, and destroy the workshop infrastructure that enables advanced manufacturing. Dr. Sarah Chen's analysis of historical technology suppression, published in Leaked Internal Communications from the Institute for Advanced Historical Studies, reveals disturbing patterns that span multiple civilizations and time periods. Her research documents over 200 instances of systematic knowledge destruction that specifically targeted technical information while preserving other types of cultural materials. The consistency of these efforts suggests not random destruction during periods of conflict, but coordinated policies designed to eliminate particular categories of human achievement. The methods employed to suppress advanced technology show remarkable consistency across different cultures and historical periods. First comes the classification of technical knowledge as dangerous or heretical, providing legal justification for its suppression. Then follows the physical destruction of libraries, workshops, and educational institutions that preserve and transmit advanced capabilities. Finally, surviving technical personnel are either eliminated, co-opted, or forced to work under strict security conditions that prevent knowledge transfer to unauthorized individuals. The intellectual infrastructure that supported ancient technological achievement disappeared with suspicious regularity during periods of political transition. The Museum of Alexandria, which had preserved mathematical and engineering knowledge from across the ancient world, suffered multiple attacks that specifically targeted technical collections while leaving literary works largely intact. The Academy of Athens, which had maintained traditions of scientific inquiry since Plato's time, was closed by Justinian in 529 AD, with specific prohibitions against teaching mathematical and natural philosophy. The school of Nisibis, which had preserved Mesopotamian technical traditions, was systematically disbanded when its territories came under Christian control. Contemporary accounts of these destructions reveal disturbing details about the systematic nature of knowledge suppression. The burning of the House of Wisdom in Baghdad wasn't random vandalism by Mongol invaders, but targeted elimination of specific technical collections identified in advance by collaborators who understood the strategic value of different types of knowledge. Hulagu Khan's forces used lists that specifically identified mathematical, astronomical, and engineering treatises while leaving historical and religious texts largely undisturbed. The destruction took weeks of systematic work, not the chaotic looting typical of medieval conquest. Similar patterns appear in the Americas following European contact. Spanish conquistadors didn't simply destroy Aztec and Mayan books indiscriminately, but specifically targeted technical codices that contained engineering, astronomical, and metallurgical knowledge while preserving historical records that served colonial administrative purposes. Diego de Landa's Auto da Fe in Mani destroyed thousands of technical manuscripts using procedures that suggest advanced knowledge of their contents and strategic value. The systematic elimination of indigenous technical knowledge created technological dependence that served colonial economic interests. The suppression mechanisms evolved to become more sophisticated over time, shifting from crude destruction to subtler forms of control that achieved the same results without obvious violence. Medieval European monasteries became gatekeepers of classical knowledge, preserving texts that supported religious doctrine while allowing technical treatises to deteriorate through neglect. The rise of university systems created institutional hierarchies that determined which types of knowledge received support and which were marginalized into obscurity. Professional guilds developed secrecy practices that prevented technical knowledge from spreading beyond authorized practitioners. Renaissance efforts to recover classical knowledge encountered systematic obstacles that suggest continued suppression policies, disguised as scholarly caution. Manuscripts that might contain advanced technical information remained mysteriously unavailable to researchers who requested access for translation and study. Private collectors who acquired classical technical texts often found themselves approached by mysterious buyers offering prices too generous to refuse, after which the documents disappeared from public knowledge. Even printed editions of classical scientific works were systematically edited to remove passages that described advanced technological capabilities. The pattern continued into the modern era, with institutional mechanisms that achieved knowledge suppression through administrative procedures rather than open destruction. Government classification systems enabled authorities to declare certain types of historical research sensitive to national security, effectively preventing academic study of advanced ancient technologies. Museum storage policies allowed significant artifacts to disappear into restricted collections, where they remained inaccessible to researchers who might reveal their disturbing implications. Academic peer review processes created barriers that prevented publication of research challenging conventional understanding of technological development. Contemporary examples of this suppression reveal how the ancient patterns continue to operate through modern institutional structures. Archaeological discoveries that demonstrate advanced ancient capabilities face systematic obstruction through funding restrictions, permit denials, and publication barriers that effectively prevent public awareness of significant findings. International cooperation that might connect anomalous discoveries across different cultures encounters bureaucratic obstacles that maintain artificial separation between related research programs. Academic careers suffer when researchers pursue lines of inquiry that challenge established chronologies of technological development. The justifications for these suppression efforts have remained remarkably consistent across different historical periods and cultural contexts. Religious authorities claimed that certain technical knowledge represented dangerous temptations that distracted from spiritual concerns. Political leaders argued that advanced technologies in the wrong hands pose threats to social stability and established order. Academic institutions expressed concern that premature release of challenging discoveries might undermine public confidence in scholarly expertise. Military organizations insisted that historical weapons research required classification to prevent modern security threats. Dr. Chen's leaked analysis reveals additional disturbing patterns in how technological suppression has been coordinated across institutional boundaries. Her research documents evidence of information sharing between religious, political, and academic authorities that enabled systematic identification and elimination of threatening knowledge. Medieval correspondence between church officials and secular rulers shows coordination in targeting specific types of technical information. Modern communications between government agencies and academic institutions reveal similar cooperation in controlling access to sensitive historical discoveries. The geographic scope of these suppression efforts suggests coordination that transcends individual cultures and political boundaries. The systematic elimination of advanced metallurgical knowledge occurred across Europe, Asia, and the Americas during roughly the same historical periods, despite limited communication between these regions. The suppression of optical and astronomical technologies followed similar patterns in civilizations that had no apparent contact with each other. The consistent targeting of chemical and engineering knowledge across multiple cultures indicates planning and coordination that requires explanation beyond coincidental timing. Recent developments in information technology have created new opportunities for preserving and sharing knowledge that threaten traditional suppression mechanisms. Digital archives make document destruction more difficult to achieve completely. Internet communication enables researchers to coordinate across institutional boundaries that previously isolated related discoveries. Crowdsourced research projects allow amateur investigators to pursue lines of inquiry that professional academics avoid for career reasons. These developments have created institutional anxiety about losing control over sensitive historical information. The response to these technological challenges has involved adaptation of suppression mechanisms to digital environments. Search engine algorithms can be adjusted to reduce visibility of challenging historical research. Social media platforms can restrict distribution of content that questions established historical narratives. Academic databases can limit access to sensitive research through subscription policies and institutional barriers. Government requests for content removal can eliminate specific types of historical information from public digital archives. The pattern of forgetting reveals itself as a deliberate process rather than natural result of time and circumstance. The consistency with which advanced technical knowledge has been targeted for elimination across multiple civilizations and historical periods indicates systematic policies rather than random destruction during periods of conflict. The sophisticated methods employed to achieve this suppression suggest institutional coordination that operates beyond individual cultures and political boundaries. Understanding this pattern requires confronting uncomfortable questions about the relationship between knowledge and power throughout human history. If advanced technologies have been repeatedly suppressed to maintain existing authority structures, what other capabilities might humanity have achieved if allowed to develop without interference? The archaeological evidence examined in previous chapters suggests that ancient civilizations possessed technologies that exceeded anything available until the modern era. Yet this knowledge disappeared so completely that subsequent cultures had to redevelop basic principles from scratch. The mechanisms of forgetting continue to operate in contemporary society through institutional structures that control access to sensitive historical information. The same justifications employed by ancient authorities, protecting social stability, preventing dangerous knowledge from spreading, maintaining established order, appear in modern policies that restrict research into advanced ancient technologies. The pattern suggests that humanity's technological development has been artificially constrained throughout history by those who understand that knowledge represents the ultimate form of power. The implications extend beyond historical curiosity into questions about contemporary technological development and the forces that continue to shape human progress. If ancient suppression mechanisms remain active in modern institutional structures, what current technologies might be subject to similar control? The pattern of forgetting provides a lens for understanding not just what humanity has lost, but what continues to be hidden from public awareness by those who consider certain knowledge too dangerous for widespread distribution. The email arrived at 3:17 a.m. on a Tuesday in March 2019, sent from an encrypted account that would be traced to a server farm in Iceland before vanishing entirely. Dr. Elena Marchetti, the archaeologist who had first attempted to study the Antikythera mechanism's companion pieces, found herself reading words that would forever change how she understood the world of academic archaeology. The collections you glimpsed represent less than 5% of what exists, the message began. The real archives are kept elsewhere by people who understand that some knowledge is too dangerous for public consumption. The anonymous sender claimed to represent a network of individuals working within major institutions worldwide. Museums, universities, government agencies, and private foundations who had become increasingly uncomfortable with their role in suppressing archaeological discoveries that challenged established historical narratives. According to the message, this network had operated for decades as guardians of humanity's hidden technological heritage, making decisions about which discoveries could be safely revealed and which must remain secret for the protection of social stability. The leaked documents that followed over subsequent months painted a picture of institutional coordination that extended far beyond what Dr. Marchetti had suspected during her restricted visits to museum storage facilities. Internal communications between major archaeological institutions revealed systematic policies for identifying and isolating artifacts that demonstrated advanced ancient capabilities. Classification protocols existed for determining which discoveries warranted immediate suppression, which could be gradually revealed through carefully managed academic channels, and which posed such significant threats to established understanding that they required permanent concealment. The organizational structure described in these leaked materials operated through informal networks that connected key individuals across multiple institutions and national boundaries. Senior curators, department heads, government liaisons, and private collectors maintained communication channels that enabled coordinated responses to potentially disruptive discoveries. When archaeological excavations uncovered artifacts with anomalous characteristics, predetermined protocols activated to ensure appropriate containment while maintaining the appearance of normal academic procedures. The decision-making criteria revealed in these documents provided disturbing insights into how guardians of hidden knowledge determined what information could safely reach public awareness. Technologies that demonstrated capabilities only decades ahead of their supposed time period might be gradually revealed through academic papers that emphasize their exceptional nature while avoiding broader implications. Discoveries that suggested ancient civilizations possessed knowledge centuries ahead of conventional timelines faced systematic suppression through storage restrictions, publication barriers, and funding limitations that prevented detailed study. Most troubling were artifacts that indicated ancient technologies comparable to or exceeding modern capabilities. According to the leaked protocols, such discoveries warranted immediate classification as civilization destabilizing and required complete removal from public access. The documents described procedures for transferring such artifacts to secure facilities operated by organizations whose existence remained carefully obscured from academic awareness. Even the existence of these facilities was compartmentalized, with most network members knowing only that certain discoveries required special handling without understanding the full scope of what was being concealed. The justifications provided for these suppression policies revealed sophisticated understanding of social psychology and the potential consequences of challenging fundamental assumptions about human technological development. Network communications express concern that revealing advanced ancient capabilities might undermine public confidence in contemporary scientific and technological institutions. Religious and political authorities had expressed worry that acknowledgement of lost civilizations with superior technologies might destabilize existing belief systems and social structures that depended on narratives of continuous human progress. Economic considerations played equally significant roles in determining suppression policies. Industrial interests had lobbied for concealment of ancient technologies that might threaten profitable research and development programs by demonstrating that superior solutions had already been achieved using different approaches. Military organizations insisted that historical weapons research required classification to prevent adversaries from gaining advantages through study of advanced ancient capabilities. Academic institutions feared that revelation of their role in suppressing significant discoveries might undermine public support for scientific research funding. The leaked documents revealed that suppression decisions often involved coordination between institutions that officially had no relationship to each other. Private collectors worked with government agencies to ensure that significant artifacts remained in restricted access. Religious organizations provided theological justifications for concealing discoveries that might challenge established doctrines. Media organizations received guidance about which archaeological stories warranted coverage and which should be ignored or minimized in public reporting. Dr. Marchetti's correspondence with the anonymous network member revealed additional details about the scope and sophistication of contemporary suppression operations. Modern techniques had evolved far beyond the crude destruction of manuscripts and workshops that characterized historical knowledge suppression. Digital archives could be manipulated to alter search results and limit access to sensitive research. Academic publication systems could prevent challenging discoveries from reaching wider audiences through peer review processes that questioned interpretation rather than accuracy. Government classification procedures could retroactively restrict access to archaeological discoveries that had initially been studied under normal academic protocols. The geographic scope of these operations encompassed institutions across all continents and political systems, suggesting coordination that transcended national boundaries and ideological differences. Communist and capitalist governments had cooperated in suppressing discoveries that threatened established historical narratives. Islamic, Christian, and secular institutions had found common ground in limiting access to technologies that might challenge religious or scientific orthodoxies. Democratic and authoritarian political systems had employed similar techniques for controlling historical information that might destabilize existing authority structures. Recent technological developments had created new challenges for traditional suppression mechanisms while simultaneously providing enhanced tools for information control. Internet communication enabled researchers to share discoveries across institutional boundaries that previously isolated related findings. Social media platforms allowed amateur investigators to coordinate research into suppressed archaeological discoveries. Crowdsourced analysis projects had begun connecting anomalous artifacts from different cultures and time periods that official academic channels kept carefully separated. The institutional response to these technological challenges involved adaptation of suppression techniques to digital environments rather than abandonment of control policies. Search engine algorithms could be adjusted to reduce visibility of challenging archaeological research without obvious censorship. Social media content moderation could restrict distribution of information that questioned established historical timelines. Academic database access could be limited through subscription policies and institutional barriers that prevented unauthorized researchers from studying sensitive materials. The leaked communications revealed growing concern within the Guardian network about maintaining control over archaeological narratives in an increasingly connected and information-rich environment. Younger archaeologists who had grown up with digital communication showed less willingness to accept traditional restrictions on sharing discoveries. International cooperation in archaeological research created opportunities for researchers from different institutional contexts to compare notes about suppressed findings. Advances in analytical techniques made it increasingly difficult to conceal the sophisticated nature of ancient artifacts that previous generations had successfully dismissed as primitive curiosities. Some network members expressed doubt about the wisdom of continued suppression policies, questioning whether the social stability arguments that had justified knowledge control in previous eras remained valid in contemporary contexts. Others worried that maintaining secrecy had become counterproductive, creating conspiracy theories and underground research communities that posed greater threats to institutional credibility than honest acknowledgement of disturbing discoveries might generate. A few suggested that gradual revelation of selected suppressed technologies might be preferable to the inevitable exposure that digital communication and crowdsourced research seemed likely to achieve. The anonymous correspondent who had initiated contact with Dr. Marchetti represented what appeared to be a growing faction within the Guardian network that favored disclosure over continued concealment. Their communications described internal debates about whether humanity had reached sufficient technological and social sophistication to handle knowledge of advanced ancient capabilities without catastrophic disruption. Some members argued that contemporary civilization's own technological achievements had reduced the destabilizing potential of revealing that ancient cultures had possessed comparable or superior capabilities. The final messages in the leaked correspondence series contained disturbing implications about the scope of knowledge that remained hidden from public awareness. According to these communications, the archaeological artifacts that had been revealed to researchers like Dr. Marchetti represented only the least threatening examples of ancient technological sophistication. The most significant discoveries, artifacts that demonstrated capabilities so advanced they challenged fundamental assumptions about the nature of ancient civilizations, remained in facilities whose existence was known only to the highest levels of the Guardian network. These facilities allegedly contained evidence that some ancient cultures had achieved technological capabilities that exceeded even modern achievements in specific areas. Precision manufacturing that surpassed contemporary industrial techniques. Materials with properties that contemporary science couldn't fully explain. Energy technologies that operated according to principles not recognized by current physics. Computational devices with capabilities that challenged understanding of what was possible using mechanical systems. Information storage methods that preserved technical knowledge with fidelity that electronic systems couldn't match. The implications extended beyond questions of ancient technological capabilities into fundamental concerns about the nature of human civilization and the forces that shape technological development. If Guardian networks had successfully suppressed evidence of advanced ancient achievements for decades or centuries, what did this suggest about the relationship between knowledge and power in contemporary society? The existence of institutional mechanisms capable of coordinating suppressions across multiple cultures and political systems indicated levels of organization and influence that operated beyond normal democratic processes and academic oversight. The leaked documents raised uncomfortable questions about who ultimately controlled access to historical knowledge and what criteria they employed in making decisions that affected human understanding of our species' capabilities and achievements. The Guardian network appeared to include representatives from religious, political, military, and economic institutions, suggesting that suppression decisions reflected multiple competing interests rather than purely academic or scientific considerations. The coordination required to maintain these policies across different institutional contexts indicated planning and resources that suggested involvement by organizations with significant power and influence. Dr. Marchetti's final communication with the anonymous network member contained a warning that proved prophetic. "The system is breaking down," the message stated. Digital communication and crowdsourced research are making traditional suppression impossible. Within the next decade, the public will begin to see evidence of ancient technologies that will force fundamental reconsideration of human history. The only question is whether this revelation comes through controlled disclosure or chaotic exposure that destroys public confidence in all institutions. The choice facing contemporary society involves not whether advanced ancient technologies will be revealed, but how that revelation will occur and what consequences it will generate for human understanding of our species' true capabilities and the forces that have shaped our technological development throughout history. The keepers of secrets find themselves confronting the reality that their traditional methods of control may no longer be sufficient to contain knowledge that digital networks and collaborative research are making increasingly difficult to suppress. The impossible arsenal of ancient technologies stands ready to challenge everything we think we know about human civilization, whether guardians of hidden knowledge choose disclosure or find themselves overwhelmed by discoveries they can no longer control.